Hi everyone, welcome back to the channel. And today we solve Leetcode daily challenge, problem number 1319, number of operations to make network connected. So it's a really long problem to read. So I'm just gonna summarize that. So basically we will be given integer n, which will basically represent the number of systems we have. And we will get an array called connections, which will show us a physical connection between the systems. For example, 0, 1 has a connection in this figure, then 0, 2, 1, 2, right? And 3 is not connected yet. So what basically we have to check is we have to check if we can connect 3 with this complete system or not, like with all this system or not, and we can make a network. So how will you connect three with the network, right? So if you have any extra edge or any extra cable, you can remove that connection and add your new system into the network. Okay. So it's going to be a really simple problem to solve. So what we're going to do is we're going to apply our DFS. We'll calculate the number of connected components, and we'll just simply return the uh, solution. So let's move toward it and I'll explain what exactly we'll be doing in the code. Okay, first thing first, I would check like a base condition. Let's say if your length of connections is less than n minus 1. So I have used n minus 1 over here because in the question it is mentioned that we will receive all the systems named from 0 to n minus 1. Okay. If it is less than n minus 1, I will simply return minus 1, that it is not possible to connect all the system into the same network. Okay. Next is I want to prepare adjacency matrix. Okay. So for that, what I'll do is let's name it a graph. Okay. And I'll prepare an array for this time. We'll take a set for all the nodes we have. Okay. So this is done. Next, just simply iterate through source and destination in connections and keep on adding that into the graph. So graph at index source will add a destination into it. Sorry, dest. Okay. Similarly, the other way around, like it's not a directed graph, so we will add an edge from destination to source as well. Okay, this is done. Next is I want to create a visited array. And instead of having a set this time, what I'll be doing is I'll keep a flag for each node. So as soon as I visit a node, I'll just mark that position as true. Okay. So we'll have initially 0 at all the places for all the nodes. Okay. Next comes the DFS part, where what I want to do is I will expect a node from which I'll start my traversal. Okay. If this node is already visited, how will you check that? If visited of node is true, then I'll just simply return a 0 that we have already seen this node in a component, connected component, so we need not to check further. If not, what I'll do, we will mark the node as visited and with check for all the other neighbors. So basically, we are preparing a connected component starting from this particular node. Okay, in graph and node. Okay, and we'll just recursively call the same method neighbor. And if it is a new node which we visited, we will return one as a answer, which will basically represent that okay, we found a new connected component into the whole graph. And at the last, I will just sum all the answers we'll get for all the nodes. Okay, and we'll subtract minus one from it. This is done. This was the complete solution. So let's check out the test cases. Okay, this. Let me check what it is. Invalid syntax. You forgot a comma. Uh, I forgot a comma. I didn't get that. Uh, what? Oh, I missed in. Sorry. Yeah. So the test cases got clear. Let's submit for further evaluation. Um, awesome. So the solution was accepted and we found, I'll say decent, like we have found 53.20% of the submitted solution. So yeah, thanks guys for watching out the video and stating the points.